Hi, it's Ken from shop3d.ca. Welcome to another monthly webinar. Today we're going to be talking about the big system here in our showroom, and that of course is the Formlabs Fuse 1 Plus SLS system. Now SLS can create wonderful prints just like this, super complex and no marks for support. My team is going to take you through how to get prints just like this, what the efficiency of the powder is like, some of the characteristics of what SLS powder can do for you, and finally, post-processing. So let's not wait any longer and dive in.
Hi everyone, I'm Pooja from Shop3D. So today I'm here to give you an overview on SLS 3D printing. So what does SLS stands for? So SLS stands for Selective Laser Sintering, an advanced 3D printing technology that uses a high-powered laser to fuse powder layer by layer without the need of the support structures. So how does it work? A thin layer of a powder is evenly spread across the build platform. A laser selectively sinters or fuses the powder based on the 3D model, solidifying layer by layer. The build platform lowers slightly, a new layer of a powder is applied, and then the process repeats. Once the part is fully printed, it undergoes a gradual cooling process. The final product is then cleaned, and then the remaining powder is either recycled or safely disposed of. The build volume of Fuse 1 plus 30 watt is 165 width, 165 depth and 300 mm height. With the 30 watt laser, it is much faster than its predecessor. It also has an inert gas atmospheric control, which actually helps improving the mechanical performance and enables sintering of the advanced material like nylon 11 CF and nylon 12 white. To ensure the optimal results, Formlabs provides an integrated post-processing setup. First, the Fuse Sift, which primarily handles the part cleaning, powder recovery and mixing fresh powder with the used powder at a correct refresh rate. And then the Fuse Blast, which actually automates the final cleaning with using glass beads, producing clean production-ready parts with minimal manual effort. Meaning you just need to throw the parts in the tumbler and it takes like 10 minutes and you just go. The Fuse 1 plus 30 watt supports a wide range of material. The nylon 12, which is a primary and used for functional prototypes, and the nylon 12 tough, which is similar to this one, but it is great for durable and small batch production. Similar to this one, there is nylon 12 white, which requires an inert gas control and it's good for visual parts. Nylon 12 GF or glass filled, usually used for high stiffness and heat resistance. Another material is nylon 11, which is flexible and good for impact resistance. Similar to this one, it also has a carbon filled, which is for lightweight and stronger parts. Lastly, the TPU90A, which is for flexible and rubber-like parts, and it is also skin safe, ideal for wearable and soft touch products. SLS printing is perfect for functional prototypes, engineering-grade parts, batch manufacturing, and customized consumer goods. Used across industries such as automotive, aerospace, medical, and SLS is also recommended where there is a need for high accuracy tolerances, especially in the intricate part geometries. So that was an overview of SLS 3D printing. Up next, we have a live demo showing the Formlabs Fuse 1 in action. See you later.
Hi, my name is William. So we just finished a 9-hour print. So now I will show you the post-process of this part. So before we get started, we actually have to put on an N95 mask as well as some nitrile gloves in order to protect ourselves from the powder. So I'll be putting that on right now. So now we will be taking out the build chamber. So we'll be starting to unlock, as well as opening the latch on the Sift. So now we will take it out, the plug out, as well as opening the latch on the printer. Now just be extra careful to not spill any extra powder. Get a firm grasp on the chamber, and now you'll be slotting into the machine. You're taking the plug out, then latching it down. And also don't forget to close the fuse here. So now I'll be turning on the fuse sift. So it's creating a negative pressure, so all the powder will stay inside. Now we will also turn on the sift. So that's what you will hear, and it will be sifting up the aged powder from the parts. Now we'll be raising up the parts. We're taking this out from the machine. So we now will be taking grasp of the aged powder and moving it to the sift over here. So it will be breaking down the parts into smaller pieces. Now there's some trapped powder in here, so we'll be taking this just to try to clean the inside of it. So now I'll be taking these 5 parts over to the fuse blast for further post-processing. I will leave these parts in the tumbler. Now I will go back in order to show you the refresh rate. As you can see here, it's currently using a 30% refresh rate. So that means it's using 30% fresh powder as well as 70% of the aged powder. So now I'll be opening up the fuse, the chamber, and filling it up. So in this process, it's taking the 70% of the aged powder and 30% of the new fresh powder and putting it down into the basket down below over here. Taking it out. So the next step is going into the mixer over here. I set the timer for about 20 minutes, so now the aged powder as well as the fresh powder will be mixing inside the chamber. So this step is very important because so that the powder is uniform, and that actually reduces the risk of print failures. So I push as much as of the aged powder down over here, so they get loaded down to the hopper down below. So it's going to be ready to be mixed with the new fresh powder as well as the aged powder, and it will go transferred into the mixer on the side over there. Once the mixer is done, it's ready to be taken out and put into the fuse hopper over here. So I'll be sending it over to Charles to show you a demonstration of how to use the fuse blast.
Okay, thanks, William. Thank you for setting up all the prints and getting it ready to go into the blast. So one of the reasons why I'm sort of taking over here is we don't want to mix the media, which is glass media that's used in the blast, and mix it up into the sift. So when things are printed and we're taking it over to the blast, it is very important that once things are here, we isolate it to specifically this work environment and not go back to the sift station, because we don't want to introduce cross-contamination over to where the material powder is kept, because that will also affect the print process. So we want to avoid that altogether, so we want to separate the stations altogether. It's checked out, close the lid. Make sure that my blast nozzle is facing the objects in the tumbler. If it's not, so this sits on a floating arm and I can adjust it so that it's a little closer because we have smaller parts here. If the parts are bigger, I would move it farther back, but since the parts are smaller, we're going to move it a little forward. We're just going to run it on a regular cycle. Really, at this point, I'm done. We're going to come back in about 17 minutes or so to check on the parts and you know, ensure that the print quality is good. So you can see once it sort of the system detects that it's up to a certain point of air pressure, it's going to start kicking off and it's going to start shooting media beads into the tumbler where all the printer parts are. Okay, so in a little bit, I'm going to come back and we're going to take a look at the final printer parts. The parts have been blasted and cleaned up and rinsed. So now we're going to come in here and see what we got. Okay, but as you can see, the part is now done and it looks very nice. So if you look at the surface, this is the type of surface that you're looking for. Same with this part. All sides are very smooth and accurate. And we're ready to ship them off. So typically there are indicators always on the Fuse 1 systems. So you'll see here, check IR sensor. So IR sensor is this unit up here. So we want to make sure that IR sensor is clean of impurities. And to clean it, we use IPA 99%. And the reason why we want to make sure that that IR sensor is cleaned is so that up here are two quartz tubes that heat up the environment chamber of the printer. And these basically acts as heat lamps. And to control these heat lamps is the value that's read off of the IR sensor. Okay, so it's very important that we keep the IR sensor clean. The next portion is the optical glass. So during and after use on the Fuse, we always want to clean the optical glass because this is the laser window, this is the camera window. The laser window is going to be where the laser power comes through this glass. And if there are any smudges or anything like that on this glass, when the laser touches that spot, it will become a heat spot. And so that will cause some problems as it will suck power away from the laser that's supposed to go onto the powder bed and draw the pattern, but instead the power is being captured by whatever it is that's obscuring or refracting on the glass. Okay? So it's very important we keep this optical surface clean. For this side, it's for the camera and the IR system. So this side, we want to keep very clean as well. Once this is clean, we're going to load it inside. Close that up. We're gonna get the previous build chamber. Do a little bit of vacuuming. And what I can tell the system is I've done preliminary checks, primed the printer. It's going to go through some of the steps that we just talked about, which is cleaning the optical glass, or optical cassette, sorry. And then it's going to do a system check, run through its checks. Once the priming checks are complete, the printer is ready to receive the next print. And you can start the next print at the printer, or because it's primed, if you have a Formlabs account, you can also go into dashboard and start a print from there as well. So you can start a print remotely once the printer is primed, okay? And that's it for me. I hope it's been informative. Next up is Michael to talk about his use case. Thank you guys for watching.
Hey, this is Michael from Shop 3D, and today I'm here to share with you a project we did for a local aluminum extrusion manufacturer and show off one of the many use cases for the fuse. This company reached out to see if we can help them reduce time and save money when cutting aluminum extrusions to the same length in a production environment. To do this, we were asked to design and fabricate jigs that would slide onto the aluminum extrusions so that they can be handled and cut in batches of 4 instead of 1 by 1. They ordered about 10 of these jigs and about 100 end caps as well. In front of me here are one of the jigs and some end caps, which were printed from nylon 12 on the Fuse 1. The jig is designed to hold 4 of the aluminum extrusions like so, and then once everything is assembled, we can put a cap on top to give it that finished look. To produce all 110 pieces took about 3 kilograms of powder, with about 1.4 kilograms of powder being sintered to produce the parts themselves. The remaining 1.6 kilograms of powder can be reused, and with nylon 12's 30% refresh rate, 70% of the powder used for a print job can be this recycled powder. In all, the total powder cost for the end caps is less than $1, and for the jig, a little over 10. The Fuse 1 is a great choice for something like these for a couple of main factors. The first factor is the precision that SLS printing and the Fuse 1 offers. Parts printed on the Fuse 1 are very accurate, and parts have very consistent tolerances. This is especially advantageous if you need to print multiple copies of a precise part. You won't need to worry then if some of the printed parts are too tight or too loose and won't fit quite right. Once the piece is designed to match the extrusion, every printed piece on the Fuse 1 will have similar tolerances. In the case of this fixture, this means that I can have it hold the parts very tightly together without having to worry about a fixture being too tight and not being able to fit all 4 extrusions. This brings us to the second factor, and that's predictability and reliability. With the Fuse 1, you'll be able to predictably set batches to print and schedule and plan around when the prints are estimated to be completed. When you follow the design criteria and workflow on the Fuse 1, you can yield a very high success rate on every print job, over 99%. Combine this with the consistent tolerances of printed parts, and you won't need to worry about defective parts throwing off your turnaround and time estimates. This predictability also makes it ideal for small batch production within a manufacturing facility, such as these end caps, and with the Fuse Blast Media Blaster, post-processing is a breeze thanks to its automatic tumbler. One big benefit of SLS 3D printing that can't be done with traditional manufacturing methods is being able to easily produce complex geometries within a given part, such as print-in-place mechanisms. In addition, unlike other 3D printing technologies that most people are familiar with, namely FDM, SLS printed parts are nearly 100% dense and are isotropic, meaning they're equally strong in all directions. This means that SLS printed parts will have comparable mechanical properties to more traditional manufactured parts, such as injection molding. Another benefit of SLS 3D printing compared to FDM and SLA is that SLS printed parts are self-supporting. This reduces the amount of post-processing required and means that the final surface quality is always unmarred. Lastly, as the physical properties of SLS printed parts are consistent, they can be designed with predictable and consistent failure points. This is useful when designing end-use parts, especially ones intended to have a controlled failure point. In all, SLS printing combines many of the best aspects of traditional manufacturing with the design flexibility of 3D printing. I hope that this use case has given you an idea of what you might want to use the Fuse one for. Next up is Cha with some best practices.
So, thank you for joining me for best practices, and I would like to share with you some of the what I've learned in terms of my experience of operating with this printer for the past 3 years. So the first thing I will mention is that the most important system in terms of having a user interface is going to be the Sift. This is going to be the most important system because this is where we manage all of our materials, okay? So it is very important that one, we keep the surface of the Sift as clean as possible. So things that we don't want to end up in the Sift are human hair. We don't want glass media that ends up transitioning in here. And the reason why that is because if it goes through the Sift and it winds up in your hopper and then it winds up in your Fuse 1, you don't know when that layer is going to show up. And if you imagine if a human hair ends up in that system and the laser comes across that human hair, it is going to cause fire inside the printer. And we definitely want to avoid that. There are fail-safes in the printer to shut down the printer in those occasions, but we certainly want to avoid that type of situation. So this is the most important area for managing materials. Once everything is sort of set in here, what I like to do is always have the lights on, and soon what you're gonna hear is the vacuum kick in. And the reason why I like having the lights on and the vacuum kick in is because this creates a negative pressure. That means if I'm handling powder in here, it will never come out this direction. It will always go into this direction. This is also very important because when we do cleanup, we definitely want to make sure that this filter right here gets cleaned up very well. The cleaner this filter is, the more powerful the negative pressure inside this chamber, and thus, again, keeping all the powder inside the Sift. All right, so that's about the Sift. We'll talk a little bit about filling and tumbling. So one of the things is you always want to check that you have enough fresh powder in here to fill up another jar and be enough to pull out all the sifted material. And what I'm going to do is I'm going to show you how we pack parts. What are some of the things to look for to maximize the use of material so that everything gets used up in the final printed part and is usable, and nothing really goes to waste, or a very small fraction of a percentage goes to waste.
Coming into this UI, what you're going to see is I've already brought in the 2 models that we're going to work with, and some quick things. We can highlight the model and then we can quickly move it around. Okay, so I'm just going to move that back to the default space. And starting from here, what I'm going to do is try and figure out, like, what is the, how can I optimize these parts so that, one, they're not touching, so I leave enough space between the parts, but also I want to make sure that they're densely packed. And I'm going to show you why that's the case in a little bit. So I want to do something like that, possibly, and then I need to figure out what I want to do with this to sort of optimize. It's kind of a chunky part, but I do want to make sure that they are approximately on the same level, and, not really touching each other. So that's pretty good. Okay, I'm going to do something like that. And so I've already gone ahead and laid out how I want the initial sort of setup to look like. So we can do this. So this will be the initial setup. Okay? This is as optimal as I can get it to get all the pieces sort of fit on one single layer and nice and densely packed. And so just quickly, you'll notice over here, this is a value that's very important in terms of what I'm trying to achieve here, which is mass packing density. And I want it above 20%. So right now, if I go and send this part off to print, right? So you're going to see I have two of these models. And I have about, I think I laid out 15 of these. And so from here, what I can do is I'm gonna use a tool which is called Array Model. I'm gonna adjust the spacing to 2 millimeters, and I'm gonna bring that up and hit apply. And you see very quickly, I'm able to sort of create a stack, and it's gonna move it perfectly straight up and down. Lay out the two models vertical, and this sort of increased my packing density a little bit. You can see over here. Now I'm gonna do this with the other models. Kind of like this, select these parts. I'm holding Shift while I'm selecting these parts, by the way. And I'm going to do the same thing. So I'm going to say array. I want a 2 millimeter gap between the models. Give me a little bit more. There we go, and hit apply. And the reason why I like this array function or tool in Preform is this tool helps me to make sure that the models that I'm bringing in are not intersecting with my previous layout and then merging models together, because you can sort of see. So let me show you what that would look like. If you have a model that's sort of interlaced with a previous model, you can sort of imagine if I send this print job off into the printer, what will happen is these two models will merge together, and I will not be able to take them apart, and that basically scraps both of these pieces because they're not going to come out correctly. But by using the array tool, I can make sure that, if I'm sort of copy pasting the model to create another layer, the array tool helps me with automatically setting the gap between the model on the bottom and the model on top. And this will help me avert any sort of issues where the models are interlaced into each other, which is important. And also this is efficient because I don't have to arrange the individual models as I'm creating layers and layers of these prints, setting them up to be in a batch, right? And I could do this consistently. So I've done that here already. So I'm going to quickly go to my next file, which is 100 pieces and 10 jets. Okay, so that's what this is going to eventually look like. So you're going to see very high packing density. I have 32% packing density shown over here. This is all the components to complete a project. I'm not connected to the printer. Otherwise, at this point, I can just upload into queue, and then I will go and prime the printer and get us set up and starting to print. Now, one thing you're going to notice, and I'll sort of point this out here, what you're going to see is on the side and on the bottom here, you see that I have a bit of a gap, and this is done on purpose. And the reason for this gap is so that in Fuse prints, once the print is complete, you don't want to take the build chamber out right away because the build chamber is very hot. And if you take it out of the printer, the build chamber is going to cool rapidly. And what will happen is, because these parts are still sort of hot, they can warp during the cool down process if they cool down too quickly. Formlabs has recommended is that after print is complete, you want to always wait a minimum of 50% of the amount of time it took to print. So as an example, if this print takes about 40 hours to print, we want to spend at least 20 hours for the cool down process. The chamber wall will cool down much faster than the core inside of the build chamber. The inside is going to be nylon powder, very dense, and so it does a really good job at insulating, whereas, the build chamber wall is basically aluminum, so that's going to sort of cool down much faster. So what we want to do during setup is have a little bit of a buffer zone, and typically it's like, I usually just use this UI as my sort of guideline, and I try to keep one square space between the printed part and the edge of the build chamber, and that provides typically enough insulation. So you can see here also, I had clicked on an estimation. So the Preform has to sort of go through a process to sort of generate an estimated total time of printing. And it has punched up a number, which is 41 hours. So it's somewhere around 40 hours or so, give or take. And so what that means is, at the end of that printing process, I want this print chamber to rest for another 20 hours after the print has been completed. And at the end of that 20 hours, I'm ready to excavate the printed part. So to talk a little bit more about mass packing density, basically this ensures that I have a good balance. So basically, when mass packing density is above 20%, basically what that means is during the material managing process, so where we set up the powder refresh rate to be 30%, what this is going to ensure is that the amount of used powder generated out of this print is going to be enough to be used for the next batch. And what that helps with is so that you don't have used powder collecting in the sift over time. So if this mass packing density, let's say, is at 10%, not at 20%, what that means is there's going to be 10% of the used powder that's going to be in excess. And it's going to sit in the sift because you're not going to be able to sort of empty the entire sift powder because there won't be enough of a mixture.
By and large, I know if I have a full chamber, it's going to take about 2.5 to 3 days for it to complete the chamber print. Within that time, I want to keep it on a battery power so that in case I lose power, I have a backup source that's going to last several hours on this unit. I am looking for something over 2 kilowatts of power storage, and I'm going to hook it up to this machine. When it's actually printing, the electric draw is significantly lower than when it starts trying to heat up everything in the chamber, okay? So you can sort of be assured. That way, when you set up full chambers to print, now I have a peace of mind. I can go do something else. Even if the power cuts out for a few hours, I'm not worried. I'm gonna come back and everything will be okay. Other best practices is follow the material guidelines. So if you're deciding to use something like nylon 12 white powder or something like a nylon 11 powder, there are specific instructions on how to start when you print with those materials. I do recommend to always follow manufacturer-specific guidelines when you're sort of working through this process. Okay, so thank you for joining me for best practices, and feel free to reach out and let us know if you have any inquiries on the Fuse 1.
Hi again, welcome back. So we had frequently asked questions, so let's get into it. So first question, we often print with nylon 12 powder. So what are the advantages of that, Michael?
Yeah, so nylon 12 is kind of your go-to SLS material. It's very versatile and it's great for functional parts. Namely, it absorbs very little moisture and is resistant to heat, light, and chemicals. Printed parts are very accurate and it has a low refresh rate, making it very economical. So Pooja, I just mentioned the refresh rate of the powder.
Yeah.
Can you explain what exactly that means?
So usually it's the percentage of the new powder added to the recycled powder for a print. Every material has a different refresh rate, but nylon 12 has around 30%, which means it's the 30% of the new powder which is mixed with the 70% of the recycled powder. So Michael, my next question is, why is the SLS printing better than the other technologies?
Yeah. So compared to other printing technologies like SLA or FDM, SLS is the most precise, reliable, and consistent, both in terms of precision and also success rate, of any of the printing technologies. Parts have the same strength regardless of orientation, and unlike SLA or FDM, support structures are not needed since the print process is self-supporting. This makes SLS great for both prototyping or end use, one-offs, or small batch production. Materials used are also well-known thermoplastics, and the mechanical properties of printed parts are very similar to those you get if you were to injection mold them. So Pooja, if I only have a few parts that I need printed, so I don't really need a whole printer, is it possible to have Shop 3D print those parts for me?
Yes, so we do offer the print services. In case if you have an STL file ready, just send it to our auto quoting tool on our website where you can get the quote, and once you have it paid, it will be printed and shipped out in 3 to 5 business days. Michael, my last question is that, is it possible to get a sample or evaluation print before jumping into like a printer purchase?
Yep, you can just reach out to us and we'd be happy to talk about your use case and see what we can provide in terms of sample and evaluation prints to help you determine if this is the right printer for you. As Pooja said, that's the last question.
Yeah.
So now all that we have is Ken with the wrap-up.
So this concludes our webinar for the Formlabs Fuse 1 SLS system. I hope you've learned a lot and are less intimidated about considering an SLS system for your business. It can really do wonders for you, and it's a very different process than some of the other printers we have. If you want to talk about your particular application, make sure you reach out to our team so we can discuss it in detail and perhaps even get a sample print done for you. Again, thanks for considering shop3d.ca, and we'll see you next time.